All right, hey guys, and welcome to this lesson on linear modeling, and let's get right to it. So the first real-world situation that we are going to try to model with a linear equation and a linear graph is this one. It's all about the federal minimum wage in the United States, and this is real information. So in 2007, the federal minimum wage was $5.85 an hour. But in 2009, it rose to $7.25 an hour. We're going to make a big assumption here. We're going to assume that the federal minimum wage has and will continue to grow at a constant rate. And that constant rate allows us to use a line to approximate this situation. If it was not at a constant rate, then it means that maybe it grew more quickly or slowly or who knows what. But since it's a constant rate, we're going to use a line to model it. Okay, and speaking of which, the first thing I always like to do is draw a quick picture to describe what's going on. So I'm going to draw a rough sketch of a graph. I think we can agree that our independent variable right now is going to be, I'm going to leave it as time. We're going to have to give it a more specific variable name later, but let's just leave it as time for now. And the minimum wage is going to be our dependent variable. Okay, so in the year 2007, I think that the minimum wage was $5.85 an hour. You can see this is a totally rough sketch, but if we were to draw a graph of this situation, it would definitely have that point on it. In the year 2009, we can see that the minimum wage had risen to $7.25 an hour. And so if we were to draw a sketch of this graph, it would definitely have that point as well. And so my question is, how quickly was the minimum wage growing? And to do that, I'm also going to use a quick table of values. Okay, so here in my independent variable, we're going to have time. In my dependent variable, we're going to have wage. The minimum wage is good, but time, not quite good enough. We're going to have to be a little bit more specific here with what that is. So I'm going to use, for the first example, we're going to do this twice. So for the first example, we're going to let our independent variable be the number of years since 2007. And we're going to give that the super unoriginal variable name x, and our dependent variable is going to be the minimum wage. And we're going to give that the super original name y. Okay, so now that we know that, years since 2007, that is going to be what goes in our table right here. Okay, so in 2007, 0 years since 2007, the minimum wage was $5.85 an hour. In 2009, which is 2 years later, the minimum wage had grown to $7.25 an hour. So let's find out how much the minimum wage increased from 2007 to 2009. So we want to find the change in our minimum wage, right? That is going to be our y. So the change in y will be $7.25, what it ended up at, minus where it started, which was $5.85. So that is $1.40 increase. So that is how much more the minimum wage was. And how many years did that take to do? It took 2 years for that to happen. So I think that per year, the minimum wage went up by $1.40 divided by 2 for a grand total of 70 cents. So that means that every 1 year, the minimum wage went up by 70 cents. And just to be thorough, I'm going to go ahead and say that the change in x, right, was, let's see, 2 minus 0. Of course, that was 2 years. Okay, and of course, this also represents this $1.40 divided by 2. That also represents, well, for a 2-year increase in time, there was a $1.40 increase in the minimum wage, which meant that for a 1-year increase in time, the minimum wage went up 70 cents. So this represents the slope of the line containing these points. And we're going to use a line to model this situation because we're told that the minimum wage is growing at a constant rate. Okay, so here's the deal. We have the slope, we've got that rate of change, 70 cents a year. And so with this definition of our variables, things get to be kind of not so bad, right? Let's make an equation to describe this situation. And I would say that the minimum wage, y, well, it started at $5.85 an hour, and it increased at a rate of 70 cents a year every year. And note that when I say that it starts at $5.85 an hour, that's when x is equal to 0. That means in 2007. So boom, we're done. That's our equation, and we can use it to do some predictions, right? You tell me some year, I'll figure out how many years after 2007 it is, I'll substitute it in here, figure out the minimum wage. Or you say, hey, when's the minimum wage going to reach 20 bucks? And I'll say, I don't know, put in the 20 bucks here, solve for X, and whatever that is, that's how many years after 2007. We predict that'll happen. Okay, but there's even another way that we can define our variables, and therefore kind of make an equation. So can I copy paste this? Can I? Nice. Copy and paste even. Oh, nice. So what if we had defined our independent variable not to be the number of years since 2007? What if it was the number of years since 2009? We're going to have to call this not x. Let's call this n. Well, the rate of change, the rate at which this minimum wage is growing, that's still 70 cents a year. It's just kind of making, instead of this being our starting point, right, $5.85, it's like we're making this our starting point. And I think here, the equation would be very similar. It would just be y equals, the minimum wage, quote unquote, started not at $5.85, it starts at $7.25. Right? It starts at $7.25. It still grows at 70 cents a year, but of course it would be 0.7 times n, right? When n is 0. 0 years after 2009, the minimum wage was $7.25, and it still grew at the same rate. And you could do some prediction or modeling using this equation now. Okay, but there's a third way to define our variables, and I want to make sure we are also well aware of this. Okay, ready? So what if we defined our independent variable, I think we'll have some space, to be not the years since anything. What if it was just the year? Just the year, that's it, year. And we're gonna call that, I don't know, P, something totally random, P. Okay. Well, now things become a little bit trickier. And we can actually use this graph to kind of help us out, because while I did write just time on this axis, you can see that it's clear that this is just the year. So here we go, just year. And so I think that if we define this to be the year, we still know the slope of this line. The slope does not change. It still grows at, the minimum wage still grows at 70 cents a year. But this line also contains the point, the ordered pair, 2007, 585. And so now that we have one point on our line and the slope of our line, boom, we're ready to make its equation. So I think that we can make this equation as y minus 585 equals the slope 0.7 times the quantity of p minus 2007. Or how I really like to write it as y equals $5.85. That is the starting point for our minimum wage, and it increases at 70 cents a year. But of course, that quote-unquote starting point, that wasn't in the year 0, that was in the year 2007. So if we substituted 2007 in for P, this would all be 0. We would of course get a minimum wage of $5.85. I really like it. And I will let you confirm that we also could have just as easily made the equation y equals $7.25 plus 0.7 times the quantity of P minus 2009. The exact same idea, that the minimum wage, quote unquote, started at $7.25. It increased at 70 cents a year, not in the year 0, in the year 2009. So another way to create an equation to model that situation.